here is the question 4. So you can see you are going to explain the chain of the boiling points for group 6 hydride because they form covalent bond with hydrogen, so we call them hydride. Now you can see the chain is not strict increase or strictly decrease. That means you need to prepare 2 sets of explanation. First is there is exceptionally high boiling point for H2O. So we can say only H2O can form hydrogen bond, but others can only form weak van der Waals force, which is weaker than hydrogen bond. So you can see we divide the hydrides into 2 groups. Either they can form hydrogen bond, which is high melting point, or they cannot, which is weak van der Waals force. So you can see we need to compare the strength between van der Waals force and hydrogen bond. That is the second mark. And finally, we come to the conclusion that, okay, so for the rest of them, if they cannot form hydrogen bond, so what depends on the strength of van der Waals force? Yes, is the molecular size. So we can compare or we can state out the molecular size, how it related to the strength of van der Waals force. Like this. The molecular size in this order. So the strength of van der Waals force or the boiling point increase in the same order. You need to show that the strength of van der Waals force in this order as the third mark. For question 5, first is arrange the order in ascending order of boiling point. Well, it's easy because again, HF is special case because it can form hydrogen bond, right? But this one got high mass. Well, this one got hydrogen bond. Seems that HCl got nothing, so it should be at lowest boiling point. That is HCl. Well, then comes with HBr and finally HF, which is the highest boiling point. The second one is why HF can miscible with water. Okay, so what is meant by miscible? Or we can say what is meant by immiscible. A good example is oil and water are immiscible. So in Cantonese is 撈得勻 or 撈唔勻, miscible and immiscible. Here is a typical example, so you should memorize this answer. Yes, first, HF can form hydrogen bond with each other and water molecule. This is point 1, right? If there is more marks, okay, it depends on the marking scheme, but the second statement, I highly recommend you to write it down. So what is the significance? Why this is important to form hydrogen bond? Is because the change in intermolecular force is small. So it favors the reaction. Yes, here shows. If the change is small, then the reaction is favored. Well, next one is why HCl is more water soluble than HBr. This question is a bit tricky because both of them cannot form hydrogen bond. We understand HCl and HBr cannot form hydrogen bond. So why they still got different in solubility is because they're different in polarity. Well, because chlorine is more electronegative than bromine, so we can expect HCl is more polar than HBr. Let's write it down. Well, this is the reason behind. So go further is we can copy the sentence from part B. During the dissolving process, the change in strength of intermolecular force will be smaller for HCl because it got more polar. As I say, if there is smaller change in the strength of intermolecular force, the molecule prefer dissolving more. So next one is you are given 3 tubes. Well, this is an interesting question. You are given 3 liquids in a tube, and there is an air bubble trapped in the end. When the tube is inverted, the bubble will flow in the liquid. You can see, or you can expect, if the liquid is more viscous, the time needed for the bubble to move to the top of the tube will be more. It is reasonable, right? And this experiment, you can do it in our science museum. They have a corner for this experiment. Measure the viscosity in ascending order. According to our idea, the most viscous one should be propane-1,2-diol, and the least one is hexane. Let's write it down. The second one is the major intermolecular force between molecules. Arrange them one by one. So we need to write down every intermolecular force. For hexane, we got only weak van der Waals force. But for propane-1-nol and propane-1,2-diol, we got hydrogen bond. Oops, I got a mistake in here. It should be propane-1,2-diol. Don't forget. So many students forget that they focus on the hydrogen bond only, but don't forget they also get van der Waals force for propane-1-nol and propane-1,2-diol. So don't forget to write down the van der Waals force. Highlight this, okay? Part C. So you are going to explain why the traveling time for propane-1,2-diol is the longest, started from comparison, right? Because you are going to explain. So first, we need to state that, as usual, hexane only got weak van der Waals force, but the other two got hydrogen bond, which is stronger. So let's write it down. Now, of course, hexane got only weak van der Waals force, you get 1 mark. But many of you may think that the propane-1,2-diol, propane-1-nol got hydrogen bond. They think they should get the other mark. The answer is no, because you need to give me the difference between two types of intermolecular force. So please write it down more. Yes, which is stronger than van der Waals force. And this, you got the second mark. Well, next one is, okay, we know that the other two got stronger intermolecular force. So why they have different? The answer is because they form different number of hydrogen bond per molecule. So let's write it down. Propane-1,2-diol can form 2 hydrogen bond per molecule. Very good. While propane-1-nol can only form 1 on average. The viscosity for propane-1,2-diol and the results in the traveling time will follow this trend. The third mark will be contribute by comparing propane-1-nol and propane-1,2-diol. You need to understand how marks are allocated. Not just tell me the fact, but also the comparison. Let's see how this question can modify. This time is the bubble going upward. What about the object going downward? Well, this is one of the past DSE questions. A ball is poured into different liquids, and they try to measure the time for the ball to sink to the bottom of the tube. The same idea. The solution with more viscosity, the ball will fall slower, right? Something more is, what about any other variation? What it could be next time? Could it be a billiard, but with a drop going down? You can expect if the viscosity of the liquid is higher, it is more difficult for a drop to go down, right? So imagine the difference between water and honey. You can expect honey is more difficult to fall down. Yeah, this is a matter of viscosity. Try to integrate different facts with the intermolecular force and you will get the answer. Page 21, you are going to explain why liquid water has higher density than ice. Well, this is one of most typical questions you can see in the public exam, so you need to memorize the answer, okay? It's very important. The point is, both liquid and water, we got hydrogen bond. Let's copy down. Of course, this is the first mark. The next mark is, what is the difference? Any special in ice? Well, this is important. In ice, the hydrogen bond formation make the water molecule arranged tetrahedrally with open structure. Well, this is most important. Without this, you cannot say anything. Between ice and water in solid, they arrange tetrahedrally, directional with open structure. But what about in liquid? Here shows when ice melts, the open structure collapses and the molecule pack closer. Well, this is the difference between ice and water. Is one of them got open structure, but one of them do not. Your answer this time, okay? The key point is your answer should not focus on yes or no hydrogen bond, because both of them got the same hydrogen bond. Your answer should be focused on the open structure. One of them got open structure. One of them do not, because the open structure collapses when the ice melts. For question 6 in page 23, so you can see the mark is not very high. Only 2 marks will be given, so no need to write down too much about scientific fact or etc. When a bottle of water is put in the freezer, ice expand. So the reason behind is, yes, we know that the ice, from the previous questions, the ice will form tetrahedrally, hydrogen bond with open structure, blah, 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 blah. Many things, okay? But this is not important because they contribute too much marks. So let's do it in this way. First, we can conclude that when ice turns into water, so I will say when water freezes, the water molecule become further apart because formation of open structure, and the result will be the ice will consume more volume and hence expand because of the open structure. The second one, this question is a bit tricky. Sucrose, for those non-biology students, you here shows the structure of sucrose. Why this is highly soluble in water? I think all of you can figure out, because the OH group, right? So let's write it down. And here shows, well, first, we have many hydroxyl group, the OH group in sucrose. This is the first point. And this hydroxyl group can form hydrogen bond with water molecules. As a result, there is small change in the strength of intermolecular force. Well, this one we always mention, right? The reason I say why this question is tricky is because, yes, it got many hydroxyl groups, so this is soluble. But if you figure out, what about starch? If those students who study biology, they will think that starch also have many hydroxyl groups. But why starch is insoluble? The reason behind is because the solubility depends on 2 factors. First is the change in strength of intermolecular force. Yes, starch can really form many hydrogen bonds with water molecule. But the second reason is the size of molecule. Starch is far too much bigger than sucrose. The big structure do not or lower the solubility. As a result, starch is insoluble. The third one is why oil and water are immiscible. So you can figure out oil is non-polar molecule, right? Let's write it down. So as a result, oil cannot form hydrogen bond with water molecules. Go further. So what? If oil cannot form hydrogen bond with water, that means oil molecule cannot break the hydrogen bond between water molecules and results insoluble. And that's it. If oil cannot break the hydrogen bond between water molecules, then how can they soluble with each other? And that's why oil is immiscible with water. For the final question of this unit, first, you are going to draw the structure of polypropenoic acid. So some of you may think that it would be a big trouble if you don't understand what is meant by propenoic acid, right? This is true. So you should put more effort in learning the naming of the organic compound. So this is polypropenoic acid, and don't forget to have an N here. Propenoic acid originally should be like this way. Let's put it into our typical format for polymer is like this. But then it turns into our answer. Next one is you try to compare between polypropene and polypropenoic acid. The previous one without COOH, so you can expect there is no hydrogen bond for polypropene. So let's write it down. The first point is here. There is strong hydrogen bond between polypropenoic acid, but there is only weak van der Waals force between polypropene. And don't forget, this point is critical, right? Which is weaker than hydrogen bond. And the result is we need more energy to break the hydrogen bond, results in higher melting point and boiling point. So you can see actually it should be 3 marks only because there are only 2 compounds. So just tell me polypropenoic acid has higher melting point. Do not contribute marks. But I want to say something more from these questions. Again, this comes from the past paper. Don't forget this is an carboxylic acid for this polymer. So what if we add sodium hydroxide inside, and you can expect there is neutralization like this. So you can see there is a new polymer. With this new polymer, we do not have hydrogen bond, but we have ionic bond. This is ionic bond. So this new polymer will be even stronger than the polypropenoic acid. But of course, that's another story. This just tells you that hydrogen bond is strong, yes, but no matter how strong, they cannot compare with the ionic bonds.